In this video, we're going to solve a particular problem which appear in JEE ADVANCE 2015. So let's go ahead and understand the problem. So here says that the limit alpha tends to 0, whatever the function is given, is equal to minus e by 2. And we need to find the value of a min. So basically, it's a problem of finding the limit. So if we obtain the limit, our job is done. Okay, let's go ahead and solve or try to find out that problem. Let's go ahead. So first we consider the limit, right? Limit alpha tends to 0, e to the power of cos alpha to the power n minus e divided by alpha to the power n. Notice that if I substitute alpha equal to 0 in the denominator and the numerator, right, we'll get the function both values at 0. So therefore it's a 0 by 0 form. So therefore the limit need to be calculated separately by some operation. So we have to first remove the singularity and make the alpha equal to 0 as a regular point and go ahead. Yes, we can apply the L'Hospital rule, but notice that if I differentiate it, right, e to the power of cos alpha and so on, right, it will be little difficult. And as well as, right, here alpha to the power m, right, will be, I don't know what is alpha to the power n, right, alpha to the power n. So therefore, how many times we will differentiate, right? It is very difficult, right? So L'Hospital will not apply here, right? So here we have to apply some standard limit, right? So let's proceed. So here we can say that first rewrite that it's equal to e to the power cos alpha n minus 1 and minus 1 by. So what we did actually, notice that in this particular job, right, we have e here. So we can take e common from the numerator, right? So therefore it becomes e to the power cos alpha n minus 1 and all that. Now notice that we are actually looking to apply the limit e to the power x minus 1 divided by x, limit x tends to 0, right, is equal to 1. So this is the one standard limit we know. So notice that here we have e to the power of something. So therefore, if I need to apply that, we need to divide the same limit by the particular value in e to the power form. So that's why we divide the denominator and numerator, or actually divide by e cos alpha to the power n minus 1, and we have to multiply that as well. So that this two will be cancelled and these two line will be equal, right? That's it. So now we have this limit. Now let's separate the limit, right? So here we just separate the limit, right? E is a constant, came out from the limit, in limit alpha tends to 0 something into some another limit. So therefore our required limit L can be considered as E dot L1 and L2, where L1 and L2 as defined obviously, right? That's the normal approach. Now if we able to calculate L1 and L2 separately, our job is done. So let's go ahead and try to find out the limit L1 and L2 separately. As obvious, we consider that L1. Now here we already discussed that e to the power x minus 1 divided by x is equal to 1 when x tends to 0. So therefore here we consider that z is equal to e to the power whatever is the exist. So z equal to cos alpha to the power n minus 1. And notice that if alpha tends to 0, so therefore cos 0 is 1, 1 minus 1 is 0. So z is also tends to 0. So therefore the L1 can be written as limit z tends to 0 e to the power z minus 1 divided by z, which is obviously equal to 1. And that's it. So we obtain the value of L1. Now our job is to obtain the value of L2. Consider the limit L2 as obvious. Now in L2, notice that we have cos alpha. So if I substitute alpha equal to 0, this is 0, this is 0. So we cannot substitute the value. So notice that we know the formula limit x tends to 0, right? The sin x by x is equal to 1. So if I able to convert that cos alpha into sine form, right, we lead to a proper way, right, or proper solution. So first, without thinking anything, just convert it. So what's the formula we know? We know that cos of 2 theta is equal to 1 minus 2 sine square theta. So therefore, whatever there in the numerator, that can be written as 1 minus 2 sine square alpha n divided by 2 minus 1. 1 get cancelled. So minus 2 sine square alpha n by 2 divided by alpha to the power m, right? So that will be reduction. So using that identity, trigonometric identity, we reduce to the respective form. Now we need that alpha to the power n, right? So therefore we need to we just go ahead and take that. So therefore it will be limit alpha tends to 0 sine square alpha to the power n divided by 2. Now we need alpha n by 2 to apply the sin x by x. So this will be whole square. So therefore we need to multiply alpha n by 2 whole square, and we have to divide by alpha to the power n. If I go ahead, we can say that it is limit alpha tends to 0, whatever exists here, and then multiply by alpha to the power, this is m, alpha to the power 2n minus m divided by 2, and so on, right? So let's write down that calculation as well. So here we divide it. Now here notice that, right? We rewrite that form as limit alpha tends to 0, alpha n by 2 and alpha n by 2 whole square, right? And limit alpha tends to 0, 2n minus m divided by 4. That's it. Let's apply the standard limit now. First, we consider alpha n by 2 is equal to t. So therefore, if alpha tends to 0, t tends to 0. So therefore, the limit n2 can be easily written as limit t tends to 0 sine t by t whole square into alpha tends to 0 alpha to the power 2n minus m. Why? Because see that these are 4 and these 2 will be cancelled out. Now it will be equal to minus 1 by 2 limit alpha tends to 0 2 to the power n minus 1. Now that particular limit we are not able to evaluate it. Okay, why? Because see that if it is evaluated, it will be 0, and here we are looking for non-zero values, right? So that's why we have to analyze it. Let's go ahead. We find out what is L1, L2. So therefore, we find that in this case, L is equal to, right, limit alpha tends to 0, e to the power alpha n minus e divided by n. That's the required limit. It is equal to minus e by 2 and all that. So with the given condition, right, it can be easily seen that limit alpha tends to 0, alpha to the power 2 n minus m is equal to 1. Now here we need to find the value of Mn. Now here, as any values of 2n minus 1, whatever value I put, right, 5, 6, 7, 8, anything, right, that will be alpha something whole or 0 to the power something. So it will be obviously 0, right? But when it will be 1, only possible if alpha to the power, this power will be equal to 0, because if I have alpha to the power 0, so then it will be limit alpha tends to 0, 1, which gives you 1. So therefore this is only possible if 2n minus 1 m equal to 0, and by calculation we can find m by n equal to 2. So therefore the given limit is holds good when m and n value, or the ratio of m and n, will be equal to 2. And that's it. So therefore for this particular problem, option B is the correct option. And that's it. Hope you understood the problem. It's a direct calculation, only we have to analyze it at the last step. Thank you.